Hello everybody. In the last video we covered how to find the basic antiderivatives of indefinite integrals, and in this video we're going to step it up. Now we're going to find more complex antiderivatives of natural log, so exponential functions, and then trig functions or trigonometric functions, all that fun jazz, okay? So let's jump right into it. All right, so our first example, we have the integral of 1 over x dx. And if you recall, derivatives, okay, your brain should think of natural log. And in this case, our antiderivative of this indefinite integral is going to be ln absolute value of x plus c. The absolute value is important because ln of x is only defined for positive numbers, so therefore we must always have these absolute value bars. My professor personally didn't care for these absolute value bars. Yours might. I'm going to do it how you're supposed to, I guess, do it by the book, okay? All right. Next example, this guy. I hope, like, in your brain you didn't think just, we're going to bang out that 3, and we're just going to go right for it, add a plus 1, because then you're going to get x to the 0, and that's not good, right? So if you ever get x to 0, it's probably because you had to do a natural log, all right? What we have to do is we have to bring that x down to the bottom. So I'm going to rewrite this integral. Ooh. We get 3 over x to the first power. Beautiful. Of dx. We can bring out that 3, right? Because our properties say that we can bring out constants. And we're left with 1 over x dx. Now, she looks more familiar, right? We get 3 times ln of absolute value of x plus c as our answer. Right? That is our answer. I don't know why I just rewrote that. Okay, that's our answer. Okay, can you guess what's going to happen here? Feel free, pause the video, try it out. Okay, we're going to bring out our constant, which is 7 over 3, so that we are left with 1 over x dx. Now we are going to find the antiderivative. The antiderivative of 1 over x, well, can you guess it? Bam. So that is our answer. 7 over 3 times ln of ln 7 over 3 times ln of the absolute value of x plus c. Oh my goodness. All right, this guy. We have the integral of 1 over x plus 3 dx. Okay, now, by chance, what do you think we're going to do? If you said to yourself, we're going to throw the whole thing in there, you are correct. Because that is our answer. This is it. You get the whole denominator inside of the absolute value bar. Okay? And I know I mentioned the negative thing earlier, but even if this was a negative, that would still be fine. It's going to be okay. All right? So let's go back to the original problem. This guy. Try this one out. I'm going to pull out this constant. Then I'm going to put that denominator inside of these absolute value bars, right? So our answer is 24 ln of the absolute value of x plus 2 plus c. That is our answer. Easy. Okay, this one I honestly did not really know what to call it, but I mean, it's involving natural log, so we got to throw that in there, right? So this is our rule, I guess, if that's what you want to call it. That is a rule. It's going to tell us how to find the antiderivative of the given integral every single time. Following this rule, we are told we must do a to the x, which is 2 to the x, right, over the natural log of a. So the natural log of a is natural log of 2 in this case, plus c. So that is our answer. Pretty simple, pretty easy. Okay, now let's try this again. Okay, practice makes perfect. Try it out yourself if you'd like. It's pretty easy. Bam, that is our answer. Beautiful. Okay, this guy. Ooh, can you guess? Can you guess? Also, if you've seen that meme where it's like, oh, she thinks he's going to change. He'll never change. And then they show like a picture of him and like it's e to the x because it's like the derivative of e to the x is e to the x and the antiderivative of e to the x is e to the x. Get it? Because like he does change. Okay, I don't know why I thought that was really funny. Okay, so based off of that little tangent there, you can assume that the answer is the following. E to the x plus c. That guy does not change, all right? So what do we do with this one? Well, I kind of created this little thing here on my own, I guess like a rule. I think it's legal It definitely gives you the right answer. But let's try this, okay? So given this rule, we were told we have e to the 7x, okay, in this case, e to the ax, over the derivative of a to the x, and a to the x is actually 7 to the x for us, plus c, okay? So what is the derivative of 7x? The derivative of 7x is 7. So this would be our answer. You can leave your answer like this, or you may write your answer, wow, that's supposed to be an arrow. Or you can write your answer like this, 1 over 7 and e to the 7x plus c. So either way is legal. You can write your answer like that or like that. It's completely up to you. All right, let's do this practice one. Feel free to pause the video, try it out yourself. Pull out the constant. Now business as usual, 12 times e to the 4x over d dx of 4x plus c. We get 12 times, well, actually I could just squish it all together, 12 e to the 4x over 4, because the derivative of 4x is 4, right? Plus c. This is going to simplify, of course, and 12 divided by 4 is 3. So our answer is 3 times e to the 4x plus c. Nice and easy. Okay, now we're getting into trigonometric functions, okay? So this is kind of like a chart or a table, right? And it's basically showing us the derivative of the following is blah, blah, blah. And then the integral of blah, blah, blah is, guess what? The derivative that you had earlier. So you can see that there's like a pattern here, right? I just wanted to show you that there's a pattern, because if you don't want to like remember all of this, you could just think backwards and you'll be able to recall it. So if you're going to write anything down, you write this down. This is the most important thing. The little chart, table, whatever you want to call it, that was just so that you can see what's going on. But this is noteworthy. You're going to need this. Okay, now let's do some problems. We have the following. The integral of cosecant squared of x minus cosine of x dx. What I'm going to do is I'm going to separate this, because we could do this by parts, right? The last video I showed that was legal. So I'm going to rewrite this to the integral of cosecant squared x minus the integral of cosine of x. Oh, dx, silly. All right. Now that we have broken it up into parts, now this might be a little bit easier. Okay, if you want to look back to your little notes here, it'd be easy to figure it out. So the antiderivative of cosecant squared of x is negative cotangent of x. And then the antiderivative of cosine of x is sine of x. But again, we have this negative sign here, right? So technically it's going to be negative sine of x in this case. All plus c. This is our answer for this guy. Nice and simple. All right, this next one. Okay, this is a little weird, but I want to show you like all case scenarios. Okay, in this case scenario, what you're going to do is you're going to find the antiderivative first. So what is the antiderivative of secant x tan x? Okay, that is literally just secant x. In general, that would be secant x. However, we do have an angle in here that's higher than x, and we have a 2x. Therefore, it would be secant 2x over the derivative of our angle in there, which is 2x, all plus c, where our answer is secant of 2x over 2 plus c as our answer. Nice and simple. And again, you could also write the answer like this. That's also legal. So you can write it like that or like that. It's completely up to you. Now let's do this one. This is our last one, yay. Okay, let's break this guy up into parts once more. And this, I kept putting a 2x. I don't know why I made these like this, but it doesn't matter. It doesn't have to be a 2x. It could be anything. I hope you know that. I feel like that's implied. But let's keep breaking this up into parts. Okay, let's do the left side. All right, we get what? Well, let's pull out this constant first and then rewrite it to make our lives a little bit easier. Okay, all right. Now that we have pulled out our constant, Let's find the antiderivative. Okay, so the antiderivative of sine in general is going to give you negative cosine, right? But we do have that angle in there, so it's going to be negative cosine of 2x over the derivative of our angle, right? Now I'm just going to do the next part. Okay, let's see. We have cosecant squared. What is the antiderivative of the following? Okay, that's going to give us a negative cotangent of x plus c, of course. All right. Now let's rewrite this. So we have negative 10 cosine of 2x over 2, because the derivative of 2x is 2, plus, because again, two negatives give you a positive, so plus cotangent of x plus c. This is going to simplify to negative 5 cosine of 2x plus cotangent of x plus c. So that would be our answer. I hope these were useful. I feel like I gave you kind of almost every case scenario, so you are prepared, I guess, mentally prepared to find indefinite integrals involving natural log e and trigonometric functions. Thank you so much for watching, and in the next video we're going to cover u substitution, so if that interests you, stay tuned for that video.